In this video, we're going to discuss some properties of non-stationary point of inflection and also to understand some details about it. Now, before I do that, I just want to go through something that I had discussed in my previous videos, that the derivative of a cubic function is a quadratic. For example, if you have the cubic function f of x, if you find its derivative, what you end up with is a quadratic. And we can use this idea to sketch these functions here, because the functions at the top are basically cubic functions. But what we want to do is we want to sketch their corresponding graphs. So suppose this point is point M. Suppose I call this point M. So suppose this is M, point M. Now, the slope at point M will be positive, okay? The slope at point M will be positive, so it will be probably somewhere here, okay? And the slope at point, at this point here will be 0, because that's a turning point, okay? So that will be somewhere there. The slope at this point will be somewhere here. Now, what you need to know here is that if you find the derivative of a cubic, you end up with a quadratic. So which basically means that what I'll end up with here is a quadratic function. Okay, you'll end up with a quadratic function because the derivative of a cubic function is a quadratic. Now, how about in the second case? Suppose this is point N. Okay, the derivative or the gradient at point N will be negative. So it will be probably somewhere around there. The gradient at this point will be 0 because it's a turning point, so somewhere around there. The gradient at this point will be 0 as well, so somewhere around there. And we know that if you find the derivative of a cubic, then you end up with a quadratic. So which means our graph will look something like that. Okay, so we have the derivatives of these functions. We can discuss other things. In fact, one of the most important things that we can say is that at this point here and at this point here, we can notice that the first derivative is not equal to 0. Okay, so you can see that at point M and N, the slope is not 0. Okay, but the slope of the slope, okay, or the slope of the first derivative is 0. So, and we can see that the slope of the slope is 0 because the gradient of the gradient is 0 at point M and N. What I mean is at this point here and at this point here, okay, 0. So what are some of the things that we can, and by the way, before I even continue, there's something else that you need to know here, is that if you look at the gradient, okay, the gradient function on the left, okay, on the left of M, we can see that the slope of the slope here is increasing. Okay, it's positive, so it's greater than 0. Here, the slope of the slope is less than 0. Okay, how about in the next graph? Here we can see that again, the slope of the slope here, it's less than 0, and here the slope of the slope is greater than 0. Okay, so there's change in concavity on the left and on the right of point M and N. So we can write our conclusions here. We call them our key points. Now, what are our key points? Our key points are this. One, at point M and N, the first derivative is not equal to 0, and the second derivative is equal to 0. So, one, we can say that at points M and N, the first derivative is not equal to 0, and the second derivative is equal to 0. Number two, we can say that at point M, concavity changes from concave up to concave down. Okay, you can see at point M, the concavity changes from concave up to concave down. Concave up because the second derivative is greater than 0. Concave down because the second derivative is less than 0. So at point M, concavity changes from concave up to concave down. Okay. Another thing we can notice is that at point N, concavity changes from concave down to concave up. So third point, at point N, concavity changes from concave down to concave up. So what can we generalize? Okay, in general, what can we say about non-stationary point of inflection? So in general, we can say that if there's an unstationary point of stationary point of inflection, okay, if there is a non-stationary point of inflection at x is equals to c, then the first derivative will not be equal to 0, the second derivative will be equal to 0, and concavity has to change around that point. So if there is non-stationary point of inflection at x is equals to c, then the first derivative will not be equal to 0. The second derivative will be equal to 0, and concavity changes. At x is equals to c. So these three things are very important, okay, for you to have an unstationary point of inflection.